Good day, everyone. On behalf of the Chartered Institute of Logistics and Transport North America, or CILTNA, welcome to today's webinar entitled Toward Decarbonization of West Coast Sea and Air, where we'll hear from two players that are leading the way, Harbour Air and HaiSea Marine, a joint venture, a majority owned by the Haisla Nation in partnership with Seaspan ULC, a company active in shipbuilding, towing, and short sea shipping, that's a tongue twister there, and ferry services. So this is a third of a series of webinars dedicated to the sustainability of our logistics and transport systems. And we're happy you've decided to join us today and hope you will see value in this and future CILTNA webinars and events. So I'm Eugene Hooven, principal and founder of EH&A Advisors, and I'll be the moderator for today's session. Just a brief word about CILTNA. The Chartered Institute of Logistics and Transport is the leading professional body for those who work or have an interest in logistics, transport, and supply chains. Founded in 1919 with over 34,000 members worldwide in over 30 countries. So CILTNA is the North American branch. Our aim is to develop the art and science of transport and logistics through education, research, networking, and information sharing. If you or any members of your teams are interested in learning more about the benefits of becoming an accredited professional member of the Institute, please visit www.ciltna.com. So as a background to today's webinar, it's become abundantly clear that there is an urgent need to decarbonize our transport systems in order to meet our net zero commitments by 2050 or earlier. Electrification is seen as the means or a means to reduce, if not eliminate, greenhouse gas emissions. However, electrification does come with a number of challenges, both in terms of the introduction of the technology, which exists for the most part, as well as the time it takes to make the energy transition from fossil fuels to electricity from renewables, and the necessary transformation of the related supply chains. Here to discuss the issues are two leaders in the field. We are joined today by Erica Holtz, Engineering and Quality Manager at Harbour Air in Vancouver, and Vince Percy, Director of Operations at HaiSea Marine, also based in Vancouver, Canada. Each will give a brief presentation, after which we will open up for Q&A. And for the audience, please make use of the Q&A function on your screen. As a quick introduction, Erica has been involved in aviation all her life, beginning her professional career in 2003 as an engineer in training with International Aero Products, where she later became general manager and person responsible for quality to Transport Canada, achieving her delegation status in 2010 as a structural delegate under the Design Approval Representative, or DAR, program with Transport Canada. Erica became one of only 10 structural DARs in the Pacific region and started her own engineering company. In 2012, she accepted a position as engineering and quality manager for Harbour Air Group of companies and is currently the project manager and lead engineer for the Harbour Air DHC2 or Beaver electrification project, commonly known as the eBeaver. She has since been chosen this year as one of 8 women who inspire by Elevate Aviation. So congratulations, Erica, on that. And with that, I turn it over to you, Erica.
Great. Thanks very much for that introduction, Eugene. I'm just going to share my screen here. All right. Excellent. There we go. Sorry about that. So to give you guys a bit of context, I think it's important that I tell you a little bit about who Harbour Air is, why electrification works for Harbour Air now, what we've done to date, what we've learned about the things we've done to date, what's next in our vision, the challenges we face, and what you can do to help keep this going. So who is Harbour Air? Harbour Air is a regional airline located in Vancouver. We service the south coast of BC, all the small coastal communities. We operate a fleet of about 35 seaplanes. It's a fleet of de Havilland Beavers, single otters, twin otters, and some Cessna Caravans. As you can see from our route map here, we typically have 30-minute average flights. It's done often at low altitude, usually below 1,000 feet. So this makes us have very low energy requirements for these very short missions. So it does make us an ideal gateway to electrification of flight. I think it's also important to note that when it comes to regional air mobility, a lot of people look at what is the market? Does it exist? And for us, it already does exist. It's one of the reasons we're looking at this is because we already have the market. We already have the aircraft. We already have the majority of the infrastructure, and we have the people. So all we needed was the technology. And with our partners, we believe the technology is ready now. So what did we do? So those who are familiar with aviation will recognize this iconic aircraft. It's a de Havilland DHC-2 Mark I piston beaver. This particular one, we took off our revenue service for this project. So it is a single pilot, 6-passenger aircraft at a gross weight of 5,600 pounds. Our plan was not to change this aircraft materially on the outside. We wanted to leave the exterior of the aircraft as intact as possible while changing the propulsion and everything under the hood. So we removed everything from the firewall forward that you see and gutted the interior of the aircraft, removed anything related to the combustion engine system. So all the fuel system, all the engine instrumentation, anything related to that system. As I said, though, our intention was not to change anything in terms of performance or flight characteristics of this aircraft. So what did we do to it? We did this. So aside from the incredible color paint job change, as you can see, the exterior doesn't look vastly different. It's got a pointier nose and a little ventral fin on the back. So we installed a fully electric Magni 500 engine and a 144 kilowatt hour lithium ion based battery pack inside the cabin. The engine is derated to be the exact same as the engine that we took off. So the power we took off was a 450 horsepower Pratt & Whitney engine. We put a 338 kilowatt or 450 horsepower electric engine on. As I said, it was not our intent to change any of the flight or performance characteristics of the aircraft because we wanted to concentrate on the novel nature of the propulsion. Electrification hasn't been done before. It hasn't been certified before. What would it actually do to the aircraft? And if we had to look at structural changes to the aircraft or flight changes, we felt that that would diffuse our attention. So we converted that aircraft in 2019. And since that time, we have performed 78 flights, exploring what changes might have ended up resulting from the change. So we looked at takeoff performance, cruise, range, climb, noise testing. It's really important, especially in urban areas, for us to decrease all emissions. So that's not just fossil fuel burning emissions, carbon emissions, but it's also noise emissions. We looked at how the cooling system would perform and some other performance-related items that are important for aviation, like Bach landing and loss of power simulations. The interesting thing with this one is we did get a performance improvement more than what we expected. And that alone really accounted for us deciding that this was worth moving forward as a viable commercial aircraft. And because I'm an engineer, I do get to throw up one data slide. This slide itself was the reason we decided we could move ahead. So for an electric aircraft, you have to, well, for any aircraft, you have to have a reserve, a 30-minute reserve. And the reserve is calculated based on your cruise power settings. So for the Beaver, it's not very efficient. Its power required to maintain level flight at cruise is 62% on the original. With the replacement electric engine powertrain on there, we were able to reduce that down to 41%. What that means is we changed from a 10-minute flight to a 30-minute flight. That, all on its own, aside from all the other good reasons to do this, made this commercially viable for us. So in addition to doing flight testing for the purposes of the engineers to gather data, we also wanted to look at operationally, how would this aircraft operate? How would it perform doing our scheduled points? What was it going to be like at the scheduled points to charge the aircraft, to manage the aircraft? So we flew it last last summer, and also this spring. We went from Richmond to downtown Vancouver. We went from Richmond to Salt Spring and Salt Spring to Victoria and back again. We did, I think, about half a dozen or 8 flights to test our operational conditions. This was really important in informing us on some of the challenges that are going to lie ahead as we continue to work towards electrification of flight. So what did we learn? I think we all know this to a certain degree, the power source carbon-free. It's not such an issue in BC, Canada. 98% of our electricity is produced by hydro. But if you're plugging your batteries in, what are you plugging it into? That's a question that we get asked every single day. We are lucky in BC, as I said, that most of ours is hydro. Recently, you may have seen some charging protocol standardization notices, like Tesla is now opening up its charging stations to other companies, and Ford and I think GM have agreed to use them. So we've all been developing our charging infrastructure based on either a CCS1 or a CCS2 protocol. And now it looks like we might all end up eventually moving to what they are calling the NACS protocol. So this is an interesting effect on the infrastructure side of it. And I think I've noted this in our challenges section about the constantly changing goalposts as we try to bring this technology into service. For us, in particular, there was a lack of power at our scheduled points. We joked it was bring your own charger. We actually had to fly a charger over with us, a little 7-kilowatt charger, and we had to wire in our own service at each of those locations. So this aircraft is capable of charging fully in about 2 to 3 hours, but because of the lack of infrastructure at the other bases, we were looking at about a 16 to 18-hour time to charge. That is not going to be viable from an operator standpoint. So there's going to have to be a significant investment in the infrastructure. I'll talk a bit more about this later, but energy storage. We need to think a little bit differently about how we manage energy. Where is it coming from? How are we storing it? How do we make sure it's available when we need it? Also from an operational perspective, the nonlinear charge rates. So a standard aircraft, when you are fueling it, the fuel flow rate is constant. It never changes. You know exactly how long it's going to take you to fuel that aircraft. When you change to electricity, once you get up to about an 80% charge, it's no longer linear. It starts to slow down. So operationally, when you're considering creating your sked strip on how you're going to place the aircraft during the day and what flights it's going to do, it's going to be really difficult to mix and match short hop flights with longer hop flights, right? Like it'd be easy to schedule the aircraft to do 15-minute tours all day. You know exactly, okay, we're going to need half an hour for charging for turnaround time. But as soon as you throw a longer charter into there, say you want to fly for an hour, now all of a sudden, instead of half an hour, it could take 2. Just to get that last bit of charge out of it. Some other interesting, just sort of, miscellaneous items that have come up for us, commonality of markings and placards, cable colors. In aviation, typically orange means flight testing, but orange is being used to indicate high voltage. There are some things we're going to have to figure out along the way there. Not so much a problem for us, but for larger aircraft, the takeoff versus landing weight. There are aircraft designs that take advantage of the fact that they burn fuel over the course of the flight. So when they land, they have a lighter landing weight. That will not be the case. Whatever you take off with is what you're going to land with. That also means that aircraft are going to be heavier when empty. They're going to be sitting on the ramp heavier. For us, that's on the water. And the ground infrastructure may or may not be designed for this condition. And of course, it's going to have a high capital cost to start up, but we're anticipating a pretty low operating cost. The other very interesting thing that keeps coming up is emergency response considerations. If you have firefighters have to be called because you did have a thermal runaway event, do they know that it's an electric aircraft? Do they know where the batteries are? Do they know where the whole high voltage lines run? Have you considered putting access ports in to ensure that they can flood the battery compartments because they need to get the cold water onto the batteries to cool them down to stop the cascading effect? I think we can borrow from the car industry here because they have templates for quick reference guides for firefighters that I think we need to make sure we're adopting as we move forward with this. Some additional lessons learned, nonlinear discharge rates. So just like on charging is nonlinear, on discharge, it's also nonlinear. And in particular, as you get to low states of charge, it can affect how much power you have available. It can affect how you design your components. It's just a different mindset, the fact that it doesn't always flow at exactly the same rate. approach to thermal management. I won't get into the weeds too far here, but it's additive heat. You're constantly heating up the aircraft. You heat it when you're flying, you heat it now when you're charging. So you're going to have to find a way to manage the thermals. There's also, we have discovered temperature differentials. So it's not just about having the batteries be too hot and worrying about thermal runaway, or the batteries too cold and worrying about losing capacity or access to capacity. There's a temperature differential that can occur by the batteries that are at the outside of the pack versus the inside of the pack, or if they're located, as in our case, as a retrofit in different locations to maintain CFG, you're going to get temperature differentials, and that is going to have a detrimental effect on the state of health of the batteries. So finding a way to condition the batteries, we don't want to be carrying any conditioning materials during the flight. That's added weight we can't manage yet. But on the ground, how do you manage battery conditioning? So again, battery life is going to be very much affected by this. And their state of charge versus your state of health versus cycle life. We're not sure exactly how that's all going to work. And if you have to replace any batteries in your strings, what does that do? Because they're going to be at a different voltage than your older strings. You might have to replace an entire string. We have discovered, because we actually have, considering how long we've been flying this, we've had the case where we've had to swap out batteries. And it's had an interesting effect on the system. It actually determined that it had a larger impact on our design choices for our next iteration than considering the failure condition. And the other thing that's really important that operators aren't going to fully understand unless they ask the question is, how does string balancing work, or sorry, cell balancing? Your balancers come on at certain states of charge. You need to talk to your battery suppliers about how that works. What does that mean? Because every time the balancers come on, it's working your batteries and will affect your state of health. So I think that it's a bit of a snapshot of the issues that we have kind of run into. There are more if you want to ask questions, but that's a brief overview. In terms of next steps for us, in the short term, we're continuing to fly this experimental development vehicle. We're trying to develop more test points to aid in determining certification basis. So we still have some questions about how the electric propulsion can potentially affect flight characteristics. You know, if we're flying at higher altitudes, does the aircraft behave differently even though we haven't changed the available power? It's a very good test bed for that, because we can simulate exactly that. It's exactly what it was before. So how does the propulsion affect flight characteristics? Does it affect flight characteristics? So this will also de-risk our validation flight test for our certification machine that we're building. And we're also really working hard right now to prove that we can do multiple flights in one day. That'll be our next milestone. So we have a second aircraft that we are building underway. The airframe is ready. We're waiting for parts, but the testing that we've done to date with this machine has really informed us that we need to revisit our planned architecture. So there were some failure conditions that we had to look at, like loss of power control. And we were going to use the Magni 350 on our second build, but we've determined that that architecture isn't going to work in a loss of power control scenario. So we are redoing that, and we hope to have that aircraft up in the sky next year. So long term, for us is, of course, to complete phase 1 and 2, which is the development vehicle, and then getting to certification with our number 2, E-plane 2.0. Our next phase would be to convert our entire fleet of Beavers. We think that that's something that is doable right now. The technology is in a good condition for us to move forward with that. After that, we are going to look at, given the technology we have, what's the next aircraft type that we're going to convert? It'll depend on what's available from a battery technology or other source of energy. And then after that, we keep going and convert the entire Harbour Air fleet. And I think that we like to joke, we're not going to be done there. We want to electrify the general aviation world, one aircraft type at a time. So some of the other challenges, not specific to our architecture, but I think are challenges to the industry, are going to be things like the technology readiness level and the rapidly changing technology. So anybody paying attention to the battery world right now, you can see there are new announcements every few weeks. Somebody's got another advancement. But the problem with prototyping and then certification is you have to lock in an architecture, because it can take 6 months to a year to even purchase parts. So you have to lock in your design, choose an architecture, and move forward with that through the prototype build and through to certification. So we may actually, when we get to certification with this thing, battery technology may be 3 steps ahead, but we can't take advantage of that until we've done the certification program. Our hope is at that point, once we've plotted that and planned that, we can have a contingency to say, okay, now it'll be relatively easy to switch to new technologies. Other challenges are going to be, as I mentioned, the dispatch reliability, dispatch changes. It's going to change how dispatchers schedule the aircraft. The operator is going to need a lot more education in how to manage the aircraft to optimize the state of health and optimize the utilization. This is something I think that in the R&D side right now, we don't spend a lot of time thinking about is how this is going to be used. And dispatchers want the aircraft ready when they ask for it. They don't want to have to wait for it to charge or wait for it to balance or wait for the temperatures to be managed. When they call you at 8 o'clock in the morning, the aircraft needs to be ready to go. What do you need to know to make that happen? I mentioned a bit about infrastructure for charging, but I think it's good to note that it's infrastructure for any of the available technologies that are coming forward for sustainability in aviation, whether you're talking about sustainable aviation fuels, you're talking about hydrogen, or electricity. What is the infrastructure? How are we going to produce that energy? How are we going to store that energy? And how are we going to deliver that energy to the operators? And I think there's a vast opportunity there for a lot of the people who are likely watching this webinar. That's where they can participate. Industry funding is a bit of a challenge. So these programs are very difficult. They take a lot of patience. A lot of investors don't really understand how certification works and the requirements. And there are literally hundreds of programs being run right now. And many of them will turn out to not be viable. And so you could run into investor fatigue, or they don't want to continue participating because you see so many potential failures. So they may shy to try again. Additionally, I would say some countries are doing better than others at instituting sustainability policies around transportation and then providing funding to meet those policies. It is in the public's interest to substantially reduce our emissions in the transportation sector, and thus both policies and funding need to be provided. On a note for us in Canada, we were very excited to see that they allocated over $350 million to the aviation industry for the development of sustainable technologies through the Strategic Innovation Fund this week. That was, we've been looking for that for a little while. But I also want to note as a secondary point to that, certification resources. The funding for our certification offices cannot be forgotten. When it comes time for governments to put forth their budgets, it is their mandate to spend the money where it is in the best public interest. And unfortunately for us, but probably good for the public most of the time, traditionally aircraft certification is low on the list. When you compare it to healthcare costs or housing or education spending, that's usually where the public wants the money to go. Aircraft certification is not well known. Nobody ever asks, where did my aircraft come from when they get on it? But it has become absolutely imperative to have our industry achieve its sustainability goals, to reduce our impact on the environment and on the public. So in order to achieve the 2050 net zero goals, I think this is an area that desperately needs more attention and funding. Because those hundreds of programs that I mentioned earlier, they're being put forth to the regulators. They're having these programs being put before them. And it is not up to the regulator to judge what is and is not potentially a commercially viable product. All they can evaluate is, can it be certified? So they're going to struggle to keep up with the sheer volume that's being put in front of them if we don't increase their resources and the toolkit that's been given to them. So what can you do? Join the transportation industry if you're not already in it. Just like every industry, we're hurting for good people. So please join us. It's one of the most exciting times, I think, in transportation and aviation in particular. It's been decades since we had a real disruption to technology. So it's really exciting to be a part of this. I'd also note, if you're already in the transportation industries, you can evaluate the opportunities that are out there. What technology is potentially available that could work for you now? And it's not just about the vehicles, right? As I mentioned, the infrastructure. Everybody can be involved in looking at solving these problems. How do we capture energy? How do we store the energy? How do we deliver the energy? And then how do we use it on the end in the vehicles? This is going to be the boring one, but join a committee. So, it is if industry doesn't help develop the standards that people need to meet with these technologies, these new amazing technologies are going to struggle to get certified and make it to market. A lot of these technologies are being developed by people who are unfamiliar with the certification process, and they need support from people in the certification community. But that means they need to come to these committees. They need to talk to these experts. The only way we're going to move forward on this is collaboratively. We need technology experts, industry experts, certification experts, and the regulators to work together to develop the standards that we need to meet. So figure out a committee that you might be able to support and join one. Last but not least, I think you can talk to your government officials. As I said earlier, they allocate money depending on where they feel it is best used in the public interest. So you need to let them know that this is your interest, that sustainability policies for transportation are important to you, that funding for both industry and our aircraft certification authorities is a priority. Because I think if we all speak up, we can affect the change that we need. Thank you. And I'll kick you over to questions, Eugene.
Erica, great presentation, great lessons learned and explanation of the challenges. And I really like that one slide, tremendous performance improvement. I think that really stood out for me. I mean, having worked for Bombardier and having done some, aircraft performance analysis and so forth in the my past life, not my life at present time, but very quick question. Before we move on to Vince, I was just wondering, the source of electrification, okay, you've got batteries, and you've also got hydrogen fuel cells. Is that also a possibility at some point for Harbour Air, or has it been ruled out as not?
No, it's absolutely a possibility. Okay. We're not ruling anything out right now. I didn't talk much about our twin otters aren't really on the list at the moment because 2 engines, too much power requirement. They will not be able to be fully electric for a very long time. So we're looking at hybrid, or we are looking at hydrogen fuel cell technology. Absolutely. It's intended that our electric engine is energy agnostic. Just get it the energy. It doesn't care where it comes from.
Exactly. Yeah. And time horizon for fleet conversion currently, what are you envisioning?
That's always a sticky question. We are currently targeting 2025 to get the first Beaver, like end of 2025 to get the first Beaver certified, right? And then it's going to be really dependent on how quickly the engine and battery suppliers can support us. Like we would ideally love a 2-month cadence, right? Where we can start converting and we could do an aircraft every 2 months to try and get done within 1 year to 2 years after that, to have the entire Beaver fleet converted, within 2 years of that, right? By sort of, I'd say, into 2028, maybe. That would be ideal, but it's going to depend on how fast they can deliver. And of course, how
the technology is going to change as well, right? So it's a kind of a moving goalpost at the same time.
Exactly. So we have to lock in our architecture now, but my intention is as soon as we get the certification of the first one, we will be looking immediately to upgrade the battery systems. That's the problem, is you're going to have a fast changeover to the next technology, because there'll be improvements that we can't take advantage of until we've done the cert program and then start the next one. So
yeah, lots of challenges there. Great presentation. So we'll move to the next speaker. Thanks again, Erica.
Thank you.
Vince, so Vince Percy is Director Operations with HaiSea Marine. Having grown up in a small fishing town and subsequently entering the field of marine engineering, Vince has been involved with the maritime industry his entire life. Over the years, he has sailed on many different types of ships, progressing from a cadet to chief engineer. And more recently, he has been fortunate to oversee the construction of 2 dual fuel LNG battery hybrid ferries. Following the vessel's successful entry into service, Vince joined HaiSea Marine as Director of Operations. So in his current role, he is responsible for operational readiness, including business startup activities, integration of shared services, contractual compliance, and steerage of the company's startup plans. So from air to sea, Vince, over to you.
Thanks for the introduction, Eugene. My honor to be presenting HaiSea and what we're doing here today. Before I jump in and share my screen, just want to add a little bit of context as well. When people look at our operations, we're often posed with the question of why hasn't the marine industry advanced the way the automotive industry is? Why aren't we seeing the innovation and change in technology? And that in its own is an entire subject that I won't exactly get into today. But the second piece to that is why is there as much concern or hesitation about the marine industry's ability to meet that net zero target by 2050 when the automotive industry seems to be more confidently moving ahead in that direction? I think HaiSea is doing a number of things that are opening eyes, and as I feel, one of the reasons why I've been invited to present here today. So I've tried to share on a high kind of strategic level what is happening with HaiSea, our project, what it looks like going forward, and where those opportunities are, and how it relates to the transportation industry in general. So what we're a joint venture majority owned by the Haisla Nation in partnership with Seaspan ULC. We're formed in 2019 with a commitment to operate the greenest tugboat fleet in the world. What we're doing is ship assist and escort towing services to the LNG carriers that will be calling on the export facility being constructed in Kitimat right now. And that is on the unceded traditional territory of the Haisla Nation. So when we talk about our successes so far and why we're gaining so much interest, I think it's probably a little bit cliche to say, but a lot of this can be traced back to a clear understanding of our core values, our vision and our mission. From the HaiSea side, we have the pillars of efficiency, safety, and care, with accountability, tying them all together as shown by the nice propeller graphic. The Haisla side, the Haisla people have lived off that land and water and resources of the Douglas Channel and their traditional territory for hundreds of years. And protection of those resources for future generations is a strong commitment from every member. So as a business, I mean, our aim is to be profitable. Same goes for the Haisla side, just as the Seaspan business side, where they want to see prosperity, and particular for the Haisla members, they want that to be ongoing and to protect the environment that they have lived and worked in for so long. I would hazard that few people have actually traveled to Kitimat here, and probably even fewer have navigated the Douglas Channel. The reason why we're in operation is care for the environment here. Our job to escort the tanker is to prevent accidents and to be there to respond in case anything does happen, and to effectively dock and undock that tanker at its port. The red line on the left shows our route, and as you can see, it travels through some constricted waters. It's not a direct route for a large tanker coming in. This is a requirement that we are there to escort them in. And when I talk about the environment, we have a short picture here that just shows the pristine nature of those waterways and what we're aiming to protect. I admit that this is a bit maybe misleading in that it's a nice sunny day where those who have been to Kitimat are familiar with the snow and wet and windy conditions. But it speaks to the true beauty of the West Coast and what we're trying to protect when we talk about reducing our emissions and decarbonizing and ensuring safety of operations and reducing events in the area. And so that the Haisla and all the locals and other First Nations who live and work in this area can continue to experience this beauty. So with that, we have to develop a plan. What is going to be our business case? How are we going to fulfill contractual needs? Factoring in our vision, our mission, our goals, and what we see as our way of operating. And many others who discuss on this subject always stress the importance of understanding their operations. What exactly is it that you're doing? What do you need to do in the case of building a ship? You know, there are many different types of ships for a reason. They all have specific purposes. And within that, we can break down the equipment on board, what specifically it needs to do. And there will identify design drivers in that too. So some of those may be our requirements to meet regulatory compliance. We operate in the emissions control area. As of 2016, there are stricter requirements for new builds in terms of CO2 emissions, sulfur oxides, nitrogen oxides. And when we're selecting our equipment, we're conscious of that as well, and trying to blend many of these components together into a matrix where we can assess the options and our alternatives to be able to apply the best fit. I've said this applies to the vessel that we're designing, but also the shore support facilities, how we're going to operate our vessel in terms of administration and business systems, what's going to be the best fit with this technology and what we've chosen. I mentioned here energy source as well. There's more than one way to get to a more efficient operating vessel. You mentioned the fuel cells, batteries as a couple that are attracting a lot of attention in the marine industry. There's LNG, there's ammonia, there's methane. So there's a lot of different choices, and you have to evaluate each one and how it fits into the overall project. And lastly, here I've included supply chain as well, in terms of reducing our emissions or our impact on the environment and the ability to develop a prosperous community and project. We need to factor that in as well. You know, constructing our operating facility locally helps, procuring locally helps. It reduces the total carbon intensity of that operation. And of course, I mentioned the things we were considering, and Erica did a great job of describing a lot of the technical challenges that go into selecting the right equipment and passing the design approval stages, and kind of that cyclical process. We would not be able to do it on our own. We're heavily reliant on the collaboration with our partners, whether that's Robert Allan, the ship designer, Elcon, the integrator, Corvus, the supplier of the batteries, Wärtsilä, the supplier of the LNG tank, its associated pack equipment, and the engines for our escort vessels. Sanmar, the shipyard that's building our tugs, and ABS, the class society that's overseeing the construction and will also be our primary class 4 operation. With that, we have a sequence of collaboration that also starts with our partner, the Haisla Nation, and local stakeholders, the client LNG Canada for us. Without their understanding of what we're trying to put together, it would be much more difficult for us. Erica described some of the technical challenge and investment, and you know, it's probably doesn't come as a surprise that some of these come with a larger capital cost. Being able to explain that to our clients and have them understand and arrange longer term contracts and create some stability for us to take that risk and reach out and try to find a solution that's going to support our needs in this case. And in that approach, we've actually seen a lot of support from people wanting to collaborate with us. People who say they love the idea, how can they support us, and really willing to provide some of that analytics or you know, joining some of those discussions about what we're going to need to move forward. So for our tugs, the equipment that we built, what this resulted in was 3 battery electric Harbour ship docking tugs. They're about 28 meters long. This is relatively representative of what you see for a lot of ship docking tugs in large harbors. The big difference here, the 5,288 kilowatt hour battery packs on board. That is roughly 75 times what's in an electric car. It represents the third largest battery install on a vessel of any type. So including cruise ships, ferries, we are putting a lot of batteries in a small tug here. And to provide a little bit more context to that too, the reason why this was an effective choice for us really fits with that collaborative approach where we had to understand our operation, what our options are, and discuss those with our partners, weigh the pros and cons, and work through with Class Society that all of this is approved, has a high level of safety, either equivalent to our traditional offerings or better. And lastly, we're not making a sacrifice. Years ago, a lot of people, when we talked about efficient vessels, that would be something slow for the automotive industry, the kind of comparison to a Prius where it might not have the power. It is not the case at all with these. They have a full speed of over 12.5 knots and a 70-ton bollard pull. For those in the tugboating industry, that is quite powerful. The key benefits here, and a piece that I'm sure a lot are interested in here, is our reduction in CO2 emissions. Going electric for us, in our case, with what's available in terms of infrastructure and the source of that power, we are able to save about 99% of our CO2 emissions for the electric ship docking tugs. That's not the case for everybody. If we were to operate this tug in Melbourne, where their primary source of power comes from coal, it would be less environmentally friendly than a conventional diesel tug. So it does have a large degree based on that well to wake view, or the primary source of your power to its total emissions. And with that, there are several options, and that's why you'll see on our Escort Tugs why LNG was the preferred option. The other huge benefit is we are eliminating other local pollutants like the SOx, NOx, and particulate matter. Erica did talk about their charger. For us, there's no standard option really available. The integrator had to build the charging equipment within the vessel, and what we're doing is supplying power cables. It is a challenge throughout industry about where you can get that electric power. Recently, we've come to understand that the earlier you start that discussion, the easier it is to resolve that challenge. If you make it clear what your aim is and what your requirements are, solutions will present themselves. It's just something that has to be planned well in advance and requires a high degree of collaboration. For our Escort Tugs, they're 40 meters, so these are bigger vessels. And I showed before that route that they travel. That's 159 nautical miles and has a significantly higher energy requirement, such that we wouldn't be able to fit enough batteries on board to complete that mission. Although we are floating vessels, not like an airplane, we still don't have enough room to travel that far on battery charges, while also being able to provide this 100-ton bollard pull and 14.5 knots to match the speed of a tanker. The emissions reductions here is approximately 30% for going to LNG over the conventional diesel offering. And in this, we also have the added benefit of reduced SOx, NOx, and PM as well, albeit not as much as batteries. However, this was the best solution as evaluated and according to what's available to us at the time. I spoke about our bigger picture and incorporating other elements, including our support facility. Those tugs will be docking as close to the LNG Canada export terminal as they can to minimize the amount of distance they need to travel to begin with. Further to that, we have our operations center floating directly next to those tugs. Again, that cuts down on travel. It helps facilitate faster, easier maintenance. It's a purpose-built, built local, powered electrically. And for crew, it also adds some comfort. We recognize that these people will be on board for continuous operation. If they're able to stretch their legs, use the lounge, use the gym in this facility, it's more comfortable in arranging a longer rotation on board where they're not flying to and from work as regularly. We recognize that not all mariners will be based in Kitimat here. We are remote. Where we are now, we've officially completed the construction of our first electric vessel. It is sailing across, it has just passed through the Panama Canal. We're going to expect it in Vancouver Harbour this summer. What we're doing looking forward, continuing to refine our operations. You know, a lot of this was conceptual to begin with. We do need to test it in real life. Now we've gone through our trials and proven a significant portion of it already. But in line with the high levels of safety that we want to provide, we do need to fully understand the vessel from an operations side as well. Now, this last slide, there's a lot to unpack here, and I suppose I probably could have broken it down into a couple different slides. But when we look at net zero emissions by 2050, the International Maritime Organization has analyzed global shipping and provided some estimations about where those cuts to current emissions can come from. For us, I've highlighted in green circles some of the pieces we've already applied, and we're definitely seeing some emission savings from the power and propulsion system that we've selected, doing electric drives on our ship docking tugs. Highlighted here, 50 to 90% savings from going full electric. In our case, we're exceeding 90% for our electric tugs, but as I mentioned earlier, that's so dependent on the source of power. For us in BC, where much of our electrical power comes from renewable resources, it's great. In other parts of the world, as I mentioned before, where if the source of that power is coal, it is not greening our entire industry. And that's why we're proud to be supporting a project where LNG is displacing some of those less green power sources. I've highlighted in orange some opportunities to improve operations here. In yellow, it's bio LNG. It is less carbon intensive. Biofuel, biodiesels. There's a huge opportunity to reduce net emissions. Some views on it show that there is a negative carbon intensity, even in some cases. And then optimizing operations, the speed of the vessels, that we will develop over time. And it ties to the other components here that I've highlighted: fleet management, logistics and incentives, voyage optimization, where that will rely very heavily on the crew. In my previous role, I've seen Seaspan ferries do that incredibly well, where they've been able to continuously improve efficiencies and reduce their CO2 emissions. We expect at HaiSea, through the use of telemetry and building a culture of trying to reduce our emissions and our impact on the environment, that we'll see continued development towards these goals of net zero by 2050. We don't know what that's going to look like, similar to what Erica was saying in terms of regulatory compliance and what regulations are coming. We don't really know. We also don't know how technology will evolve, but we have to start somewhere. We feel that we've created a great platform and are setting ourselves up for that continuous improvement over time as well. With that, I think I will turn it to the question period, if that's all right.
Great, Vince, and I like that M&O facility. I think that certainly enriches the job for many in the field. And I really like the guidance that M&O, the IMO has put out, which is very, very similar to what the International Civil Aviation Organization is doing for aviation, and where I used to be representative. So it's nice to see those similarities in terms of the different sectors grappling with net zero and what that all means, and the multiple choices that one has and decisions that one needs to make. In terms of the energy choice and propulsion, I think you made a good point that it really depends on the mission, right? And I think, yeah, Erica mentioned the same thing. The type of vessel and power source and propulsion really depends on the mission. So I think ultimately for HaiSea and Seaspan, will you also have kind of a hybrid or a mixture of different propulsion system ships and energy sources, and how will you manage that? I mean, it'll be a lot more complicated or complex, if you will. What are some of the challenges that you see there?
Yeah, I think the two different ships represent that mix of energy sources. We mentioned the electric ship docking tug, where they do the ship docking and undocking portion of the Escort. Mm-hmm. The great benefit to us is we had a large supply of electricity available to us to facilitate that charging. Mm-hmm. That's the benefit of the infrastructure that's being put in place in Kitimat for the LNG facility to begin with. In terms of our additional mix of energy sources, our Escort tugs are LNG powered. Mm-hmm. They do use diesel as a pilot fuel, and in both cases, I did highlight the potential for biofuels. Now there is a bit of a challenge operating in a cool climate, and where are we going to get those from? Mm-hmm. The other side is technology changes. We've seen the energy density of batteries decreasing over time. With our understanding of our operations, the telemetry and data collection and analytics that we're providing and using in our ongoing operation, we'll be able to make that decision along the way. Does it now make sense to incorporate, perhaps some batteries and hybridize the Escort operation, or mm-hmm. can we transition to a different fuel source if required? That being said, with the current targets, some visions to minimize reductions or reduce by 30% in the next 10 years. We're already largely there. So in terms of regulation, there isn't a big concern. But in terms of the business case, what's available on the market, and that alignment with our goal of ensuring that both partners are prosperous, and that we have a sustainable operation that maintains the natural beauty in the area that the Haisla have lived and worked in for so long. Looking to apply solutions where we can.
Right. Well, great. I'll open it up for Q&A. I'll ask you all to so all three of us are on. I'll go through some of the questions that we have. Probably won't get to all of them. We may go a little over the hour, but that's fine. I guess, Vince, you spoke about collaboration, and Erica, you as well, and I think that's the big word these days. When you Google business collaboration, you come back with 1.2 billion results. So it's one of the key words that's being bantered about quite a bit, and I certainly have. That's been a big part of my career in terms of innovation and getting change and going and so forth. But what does that mean for you specifically? What does good collaboration mean for you, and what efforts do you need to take to make that a meaningful endeavor? Erica and then Vince. You're on mute.
Right. I think I mentioned a little bit about the standard collaboration, right? Like making sure we have standards, because the regulators, it's not like they suddenly magically know everything and they can set the goalpost and say, here's the hoop, jump through it, right? Industry is where most of the technical knowledge is. So they need to work together to figure out what is the appropriate safety standards, what is the appropriate design requirements for this technology. And then I think also on the industry side, I know that there is a lot of, we all want to protect our IP, but I think it's really important for us to share our lessons learned, to share the challenges, to talk about those openly and discuss ways to overcome them, because not one of us is going to be able to do that on our own. I can't solve every single issue. I'm more of a problem identifier as the end user, not necessarily going to be the problem solver for infrastructure or some of the component level stuff. So I think it's really important that we set aside our yes, protect your IP, but share your lessons, share the challenges, so we can work together on it as an industry as a whole.
Yeah, and I guess also being open about what you are, what you can, or what you know and what you don't know, and be very open and transparent.
Acknowledge, exactly. Every time we learn something, we learn that there's a lot more that we don't know than we do know.
Exactly. Yeah. Vince, anything to share on collaboration?
Yeah, I would mirror that as well in terms of being as open and transparent as we can be. Of course, there is an element of IP that needs to be protected, but also getting the right people talking. When I talk about the number of contributors to our project in terms of class, in terms of propulsion providers, to have the proper discussion and identify what we don't know and understand what our solutions are that kind of meet those aims that we're after. Yeah.
So we've got a lot of questions here. So I won't be able to get through all of them, but I'll certainly try. I think one element or question regarding to the eBeaver is about de-icing. From Mark Reeve, who's got a number of questions. Inquisitive as he is, I know him for being quite a inquisitive individual, so that's great. But yeah, you didn't touch on that, and certainly de-icing is an issue in aviation. Erica, any thoughts on that?
Right. So yeah, I see the entire question there. So I'll answer the payload. So in the Beaver, I said it's a 6-passenger aircraft. We are taking the rearmost seat out to make room for the batteries. So we lose 2 seats. So our max capacity is going to be 4 passengers, for the foreseeable future. As I said, it's also going to be iterative. Our first STC is likely going to be 2 to 3 passengers, and then we will do a design iteration for the next aircraft build to take advantage of the full 4. We do not currently have a de-icing system on the Beaver. Most of our fleet is prohibited from flying into icing conditions. So that's not something that's really on our radar right now. I do know on our ops side of the house, it is something they've been talking about, is what could we do to our fleet to make it so that it could fly into icing conditions. I'm not sure we'll get there with the eBeaver, but we are looking at that with some of our other aircraft types.
Yeah, that brings up a whole other topic of micro weather and having better met data and information, and so the technology is probably there. It's a question of getting some of that information to. And
if we could fly into icing conditions, you get any ice buildup on the wing, yes, it could slow the aircraft down, which would affect the battery endurance. Because if we're flying slower, we're less likely to get to our destination, or have less reserve when we get to our destination. So
or cause an incident or an accident, which
nope.
No, okay. Yeah, no, still a lot of questions here. When using traditional fuel, a plane can fly by using fewer and fewer fuel. Okay, I think it's kind of been addressed by that when.
I think what it's doing is sort of, again, like you decrease weight over the course of a flight because you burn fuel, and the lighter you are, the less energy it takes to move you through the air. We are a constant load through the entire flight. So the power required for level flight will remain constant. It will not change. Yeah.
That's a key difference.
It's a key difference. Yeah.
Then I have a question here from Paul Miller. Is there any value in providing solar charging on your aircraft? What are the capital costs? Has that been explored at all?
We haven't delved very far into that. As I said, though, we rule nothing out. If it becomes a good idea to put solar power to make it last longer, absolutely we will look into that. But I think the way I look at it is we're trying to eat a very large elephant and we're doing it one bite at a time. We're going to finish this bite and then we'll look at other technologies that we can add on.
Yeah, and one other question that kind of prompts me as well to ask a question about any changes in operations, particularly when it comes to air traffic control, air traffic management. Are there any special considerations that need to be understood or adopted within the system?
Right. We don't know of any yet. We've been flying in the YVR air traffic control region for the past 4 years. We do know that they treat us very well. They're very kind to us and give us very good routes. But I would say ultimately, if our intention is to be able to replace combustion engine aircraft with electric aircraft, we should not change how they operate. If we change what aircraft ATC has to do with them, I'm not sure we've accomplished or succeeded at our goal, right?
Yeah.
So at the time, I don't see any. Right now, I don't see any. We haven't had any come to light.
Yeah. Yeah. I mean, typically in flight planning, you've got your reserve fuel and so forth, but that's
we're going to be maintaining all those operational rules. So
yeah. Moving right along, I have one question here for Vince. Very interesting presentation. Could you provide more information about your client LNG Canada? Many in the audience will not be familiar with the huge LNG project.
Yeah, it's not really my project to speak about. There's a lot in the media about it. It's a joint venture partnership where they are exporting LNG from Kitimat to the world.
Yeah, so the Haisla Nation has really taken a lead role in this in that whole development, and I think importantly, of course, is they want to ensure that their environment is protected at the same time. So I think really interesting. Yeah.
To add my own opinion on the matter, I mean, it was in my presentation where I said, to be able to support the transition of other regions from like coal-based power with very high CO2 emissions to something much cleaner, in this case LNG, I think it's a benefit for the world.
Well, I think we've kind of come to the end of we're 2 minutes over, 3 minutes almost. Thank you both very, very much. It's been really, really interesting, and it's always exciting to see what's going on, but then also to see what's the similarities between the different modes of transport and the challenges that are faced as somewhat similar. They're different, but they're very similar, and the path forward. So thanks for bringing this out, and we'll certainly the presentations will be posted, and the recording as well for those who are online, and for anyone else who wants to listen in the future, it will be available. So thank you very much, and I wish everyone a good rest of the day and a good weekend. Bye now.
Thank you for having us. Bye.
Thank you. Bye-bye.